Conductors and conductor sizing are fundamental parts of electrical work. To understand why certain materials are used as conductors and how wire size is determined, we need to take a quick look at some electrical basics, including atomic structure, outer energy levels, and free electrons. All matter is made up of atoms. An atom consists of protons and neutrons in the nucleus, with electrons orbiting the nucleus and energy levels. Electrons carry a negative charge, and their movement is what creates electrical current. While atoms contain multiple energy levels, the most important one when discussing conductors is the outer energy level, also known as the valence shell. In some materials, the electrons in the outer energy level are loosely held. These electrons can break free from their atomic bonds and are referred to as free electrons. When voltage is applied, free electrons begin to move through the material. As they move and collide with other electrons, an electrical current is produced. Materials that allow electrons to become free easily will allow current to flow more easily. This brings us to conductivity. Conductivity describes how easily a material allows electrical current to flow. A material with many free electrons has high conductivity and low resistance. A conductor is a material that provides a low resistance path for electrons to move. Conductors are used in electrical systems to deliver power efficiently and in a controlled manner. Several metals are commonly used as conductors because of their high conductivity. Silver, copper, gold, and aluminum are all very good conductors. Silver is the most conductive, but its price causes it to be less common within the industry. Gold conducts very well and resists corrosion, making it useful in electronics. Copper is the most widely used conductor in electrical wiring because it offers excellent conductivity at a reasonable cost. Aluminum is also used, particularly in larger installations, but it must be larger in size to carry the same current as copper. Conductors must be used along with insulators. Insulators are materials with very few free electrons, which means they resist electrical flow. Insulation surrounds the conductor and ensures that electricity travels only through the intended path. Since electricity follows the path of least resistance, insulation prevents current from flowing into unintended paths, such as through a person or between conductors, which could result in shock or short circuits. As voltage increases, insulation must be rated to withstand higher electrical stress. Higher voltage requires thicker or higher rated insulation to prevent breakdown, arcing, or failure. This is why conductors are manufactured with specific voltage ratings. Conductor sizing is the process of selecting a wire size that can safely carry the expected current. The primary factor in conductor sizing is current, measured in amps. As current flows through a conductor, resistance causes heat. If a conductor is undersized, excessive heat can build up, damaging insulation and creating fire hazards. Larger conductors have lower resistance, allowing them to carry more current safely. The conductor material also affects sizing. Copper can carry more current at a smaller size than aluminum, which is why aluminum conductors must be larger for the same application. Let's walk through a basic conductor sizing example using an American wire gauge chart. Suppose we have a circuit that is expected to carry 20 amps. The first step is to reference the AWG chart to find a conductor size that can safely handle that current. Looking at the chart, we can see that 12 AWG copper is commonly rated for 20 amps under standard conditions. If we were to use a smaller wire such as 14 AWG, the conductor would overheat at this current level. If aluminum were used instead of copper, the wire size would need to be increased because aluminum has higher resistance. This example shows that conductor sizing is not just about making a circuit work, It's about selecting a wire that can carry current safely without excessive heat. While electrical concepts like atoms and electrons help explain how conductors function, the main takeaway is that conductors rely on free electrons, and conductors' sizing ensures those electrons can move safely. Proper conductor selection improves safety, efficiency, and reliability in electrical systems.